Okay, let's talk about the DOS now. So density as a states is a way more visual way to represent, and I think a more intuitive way to represent what we're talking about here. The density as a states can tell you a lot about what's happening with the chemistry. If the system's metallic, if you want the system to be metallic or not metallic, can you dope it with something? Can you force this Fermi level to shift or change to meet the needs of whatever system or material you want to make? Okay, so the density is the states, the number of states. It's the number of states in a given energy window. So, no, when I say states, I mean electronic states. So like d orbitals being that way, we have 5 states or 5 degenerate states. It's trying to keep track of the number of states at that energy. Energy, which is equal to dN. I'm going to have another differential down here. What is going to be on the bottom? So N is the number of states. Yep. Okay. You see a differential. In calculus, what is a differential? Derivatives, yep. Slope. That's the part I want. So what this actually is it's a slope of the band structure. Bless you. It's kind of quoted with taking it out of reciprocal space and putting it in real space. What it can tell you is you can look at the band structure. The band structure is related to the number of states that have that energy based upon that K vector, and you can transform it into a density of states. We're already at the end. Time flies when you're having fun. I'm super hungry. The time change absolutely sucks. Whoever decides that we're going to have Halloween, elections, and time changes all in the same week can go straight to hell. I'm like so tired. You guys got to be even worse than me.
No, I actually got a migraine and went to bed at 9:30 last night. So I stayed up till 3 watching the election.
Here we go. We got our energy. This is our band structure for a 1D hydrogen chain. What's it look like?
It's going to go from down to up.
Okay, great. Let's draw our density as a states.
It's going to do a really cool thing where it like does this.
Well, let's look. So dN, dE, number of states. What's the slope approximately here?
0.
So what does that mean the differential is approximately here? Not 0.
1.
Not 1. Will be a yeah. So this is approaching 0. It's not 0. So what's going to happen to the number of states at this point? Up or down? Okay. What about up here, where it's flat?
Also not up.
What about in between? There we go. Little demon horns.
Chemistry, satanic, get rid of this.
Yeah. Yeah.
No, it's demon.
So now this is known, these devil spikes are known as Van 't Hoff singularities in some cases they're called. Where's the Fermi level here? in the middle right here. Now, where would I draw it in the DOS?
At the lowest point of the keyboard.
What was that?
The middle of his forehead. Yeah.
There we go. Here's my EF. That means I'm going to shade it in. You might not see this all the time that way, but that means electrons occupy there. How do I know the 1D hydrogen chain is metallic? I mean, that's what I see, but what's your reasoning? How would you be able to tell that this system is metallic? Is there any separation here? No, there's no separation. There's empty densities of states here for the electrons to populate into. It can oscillate at that point. So if you have a densities of states at the Fermi level, you have a metallic system. How metallic depends upon a bunch of other parameters, but it's correlated to if you have a lot of empty or a lot of densities of states near the Fermi level, the more metallic you are. That's a very general rule, though.
Make sure that
Okay.
that explanation.
Yeah. Before I get flamed by a bunch of people. Now let's see, I had that, and my EF is here. Not metallic, could be a semiconductor. What would you do to make the system metallic?
Dope it with some.
Yep, if you dope it with something electron rich, what's going to happen?
Would you say electron rich?
Yep, I mean more electrons than the base system. We're going to bump up here. Suddenly the Fermi level is up here. What about if we remove electrons? Yep. If we remove electrons, it would be down here. So if we're looking at this system, we're really at the lowest point of the metallicity here, right? We'd either have to remove or add electrons. What would you do?
Depends on level.
So dope them with more electronegative elements, going to pull that density away. Or you add in alkali metals, alkali earth metals to pump this up.
Yeah, but why would you do that?
Because you're shifting the densities of states higher at the Fermi level,
Or why-
making it more metallic, hopefully making a superconductor. That's why my advisor, she looks at studying systems where they throw in those elements. All right, that's about all the time we have today. Are there any questions we got?
I think the last 5 minutes is like the most important.
Yeah, I think so too. It all comes down to the end.